So today I'd like to talk about how aerials, mobile phones, Wi-Fi routers, things like that work, because they all work in essentially the same way. So something to go over first is that atoms are like a base unit of what makes up everything. They're little Lego building blocks essentially of everything that's made up. And within those themselves, they're made up of three individual types of particles. They're called protons, neutrons, and electrons. And protons and electrons are charged particles. And all that really means is that if you try put something of the same charge towards them, they'll repel it. So, if you put a north and a north of a magnet together, it repels it. You put north and a south together, it attracts it. So it's essentially the same as magnetism. It's just a force that we can use. And because they're charged and can put forces on things around them, we have to find a way of explaining the fact that they can actually act at a distance, it's called. And the way that we explain that is by using field theory. And a field is essentially an area of influence around it in which it can act in. And it does that by using these tiny little particles, but they're not particularly relevant for what we're going to talk about. So the fields that come off these charged particles are sort of like waves on the ocean, in that if we move the particle around, the field varies as well with it. And it follows. Same way as if you run your finger around on the surface of the water in a bath, you'll leave waves travelling out from where your finger was. And that's essentially what we do to create signals. So you would take some wire, and then using, say, a magnetic field, you would force all the electrons that are in that wire to go to one end or the other. And then, because they're all bunched together, they create quite a large field because they all add up, they're cumulative. And then as we move these electrons about, we force these waves, like they would be in the water, to be created within the field. And that's what things like radio signals are, microwaves, and the things you receive to get like your television, your phone calls, things like that. So we would push all the electrons to one end of the wire, and then bring them all back. And then that creates, a big ripple in that field. And then that ripple in the field travels out the same way it does on the surface of water. And the clever part is we can do something exactly the same at the other end to detect it. So if someone gives out a little ripple at the other end, we can have a wire again, but with free electrons in this time. We're not doing anything to them. And then this ripple will pass through that wire, push all the electrons to the end like we originally did to the transmitter, and then we can measure how far it's made the electrons move towards one end of the wire, which is called the voltage, and then we can turn that into binary. As a simplified version, we could say if we push all the electrons to the left end of the receiver, then that means that's a 0, and if we push all the electrons to the right end of the receiver, then that's a 1. It's more complicated than that in that when we actually measure off the voltage, there are different codes for every different voltage number. So we read off these voltage numbers, and we've already told each other what each voltage number means in terms of binary, and then we put that through a computer code, and it comes out with it telling your device what to do.